Okay, hi guys, it is Mr. Rocco again. This will be the second video for this week of September 14th. And in this video, we're going to talk about measurement. So that's the first slide, measurement. In the last video, I talked about observations versus inferences. So recall that observations use your senses, right? See, touch, taste, hear, smell. And an inference is just an extension of your observation, making a guess, making a prediction, making a hypothesis. So measurements actually tie in with observation. So an observation is, again, using your senses, and then a measurement is using an instrument to create a more accurate observation, right? For example, I could be walking down the hallway in the high school and see a student walking toward me, and I see a boy coming at me, let's say, and I say, that boy is tall, right? If I see a boy and I say, that boy is tall, that's an observation, right? I can see that he's tall. But then if I want to be more accurate with my observation, I could get out a meter stick or a yardstick or a tape measure and actually measure the height of the boy. And I could say, that boy is 6 feet 4 inches tall, right? He's 6'4". That's a measurement, right? I measured the boy, but that's still making an observation. I'm just making it more accurate. So I could say he's tall, or I could say he's 6'4", right? So measurements are actually just being more accurate with our observations. And there are two systems used today. We still use what's called it was from Britain, right? The British system. It was called the British Imperial System, or we call it the English system. There's only a few countries that use it. We're one. Myanmar and Liberia are the other two that use it, but most of the world uses the metric system, which is known as the SI system. SI stands for System International, or International System of Units. The United States, we started using, I believe, the metric system in the late 1800s, but it's not an official. We never officially adopted it as our system of measurement. So it is obviously legal to use it. We use it in schools, right? You learn about the metric system as we're doing now, but it is not our official metric system, or our official measurement system, sorry. We still use the English system or imperial system. These are some basic differences, which we're going to go into more detail in a minute. So on the left here, this is showing you commonly used English system measurements. Like we measure things in inches, feet, yards, miles. And here's some equivalents, right? A foot is equal to 12 inches. A yard, right, if you're talking football, every yard is 3 feet. A mile is equivalent to 5,280 feet. We measure our volumes, fluids, in ounces, or cups, or pints, or quarts, or gallons, right? These are, again, equivalents. A cup is equal to 8 ounces. A pint is equal to 2 cups. 2 pints equal a quart, or 4 quarts equal a gallon. So those are just some comparisons. We have weight. We measure our weight in ounces and pounds and tons, right? 1 pound is equal to 16 ounces, and a ton is equal to 2,000 pounds. Luckily, we all use the same time, which would be very confusing if the United States used a different time measurement than other parts of the world. So we use seconds, minutes, hours, days, weeks, and years, and you know your equivalents there. Temperature, a little different. So if you travel, I remember as a teenager, we took some summer vacations up to Canada, went to Montreal one year, went to Toronto, and they measure their temperature, as you can see over here on the right, in Celsius. So they might say it's going to be a mild day, not hot. The high might be, 20 degrees. And you're going to say, what? 20 degrees? That's cold. But 20 degrees Celsius, right, is equivalent to around 68 or so degrees Fahrenheit. So that's a little bit tricky when you travel to places like Canada and other parts of the world. We use Fahrenheit, right? It's going to be 80 degrees, that's a nice warm day. Or it's going to be 95 degrees, right? Really hot. And then speed, we use miles per hour, whereas again, because we measure in miles, as you see up here, over here, they're using the meter or the kilometer, so they're going to measure their speed in kilometers or kilometers per hour. So these are the metric units over here. Instead of miles and feet and inches, they use the meter. Instead of ounces and pints and quarts and gallons, they're going to use a liter. Instead of pounds and ounces, they're going to use the gram. And again, time is the same. And then temperature is Celsius instead of Fahrenheit. So let's go through the different types of units. There are what are called standard units or basic units. A basic or standard unit does not need to do any kind of algebra. You don't necessarily need to divide or multiply or plug it into some kind of mathematical formula to come up with the correct number. So there's 4 basic or standard units in measurement. The first one is length. Length is just the distance between 2 points. And we use the term length for certain things, but sometimes we use variations that we use words that mean the same thing, but they have a specific dimension, a specific way we're measuring. For example, height. You don't walk up to somebody and you say, hey, what's your length? They're going to look at you like, what are you talking about? You say, what is your height? So you know when you say to somebody, what is your height? You're talking about from the bottom of your feet to the tip of your head, right? You're going vertically. So we know, or what is the height of a building, right? From the bottom floor to the top. And so we know that's a dimension we're measuring vertically. But that is a length, right? You're going from the bottom to top, going from one point to another. Or width, right? You want to measure the width of a room, right? Or the width of a box. So you're measuring, again, from one side to the other. Or depth, right? You could look at a swimming pool. You could say, what is the length of the swimming pool? Which means you might be measuring it from one side to the other. It might be 25 yards. Or you say, what is the depth of the swimming pool at the deep end? Let's say if you go to the Rhinebeck Rec Park and you want to measure the depth there, I think it's, I don't know what it is, 12 feet, let's say. So you're going from the surface down to the bottom of the pool, right? Going vertically. The basic unit for length is, and we're going to stick with metric. In earth science, it's basically all about the metric system. So the basic unit is the meter, right? So a meter is, of course, the wooden stick that you probably used in middle school. Now you have to be careful because there's a meter stick and there's yardsticks. I get many students over the years, they come in and say, Mr. Rocco, can I use this yardstick? And I'm like, it's not a yardstick, because technically a meter is slightly more than a yard. Right? A meter stick is about 39 and a little bit more inches. A yardstick is only 36 inches. So it's at least 3 more inches longer as a meter stick than a yardstick. Mass. So mass is how much matter you have, how much stuff is in an object, right? Mass is measured in grams. And again, that's the basic unit in the metric system. Weight is different than mass. And again, be careful when you use words. Like words in science do have different meanings, right? If you say to somebody, what is your mass, right? That's how much matter are you made of. You're so many grams or so many kilograms. If you say to somebody, what is your weight? I mean, that's different. That's going to depend on what planet you're on. I mean, obviously we're on Earth, but if you were to go again to the moon, right? The moon has a different force of gravity, right? And I'm sure you're aware of this. Gravity affects your weight. The moon is about 1/6 the force of gravity. So actually, if you took your weight on Earth and divide your weight here by 6, divide by 6, that's going to be what you're going to weigh or feel weight on the moon. 1/6. That's why if you see them take a leap, they take a big giant leap, right, on the moon, right? The famous quote there, one small step for man, one giant leap, right, for mankind, etc. That is weight. So weight is different. I know if you go on Google, you can find different weights on planets. Like if you search in Google, just say, what is my weight on other planets? And they'll give you this calculator, and you just punch in your weight on Earth, and it'll tell you how much you weigh on other planets. And I believe Jupiter, being the biggest planet and the biggest force of gravity, I want to say off the top of my head, is about 5 times. So if a person on Earth, let's say you weigh 120 pounds, again, sorry, I'm writing with a mouse, which is a little tricky. 120 pounds on Earth, you would have to multiply that times 5, which is working out to be about, 600 pounds. So if you weigh 120 on Earth, they're 120. That's not a very, big person, which it isn't. But then you go to Jupiter, Jupiter, you're going to weigh about 600 pounds. So it's going to be tougher to pick up your feet. So you got length, you got mass, you got time, which again, everybody in the world thankfully uses the same unit. Although the military, if you know military time, right? Military uses a 24-hour clock. So when they want to say 6 a.m., they would say 0600. All right. Once you get to 12 o'clock noon, right? Lunchtime, let's say, is 12 o'clock, and they want to do dinner time. Maybe your dinner is 6 p.m., right? We would use 6 p.m., but they would use 1800 hours. They're going to add 6 hours to the 12 hours, and that's where they get the 1800 hours. So there's a big difference between 0600 and 1800. 0600 is 6 in the morning. 1800 is 6 in the evening. Right, so they use a military time. But we all use the same basic units, right? Seconds, minutes, hours, days, months, etc. Time is the duration. Duration is a word. We'll get to that when we get into sunlight. Like right now, when you look at the length of a day, they call it the duration of insolation. Insolation, not insulation like in your walls. Insolation meaning sunlight. Duration of daylight. So our duration of daylight actually right now is going down, decreasing as we passed the summer solstice. So back in June was when we had the longest daylight hours, and now we go into heading toward fall and winter. Our daylight hours are getting shorter, and you probably noticed that it's not as bright in the morning. It's getting darker, and it's also getting dark out earlier every night, right? If you go back to 4th of July, Independence Day, we were having daylight till 9 o'clock, 9:30 at night. Now you can see it's getting darker at around 7:30. It's 7 o'clock. And so as we slowly head into the next couple of months, October, Halloween, Thanksgiving, the daylight will get even shorter and shorter. And then once we get past the winter solstice, we'll start turn the corner and go the other way and start increasing. So that's duration, how long something takes. So you have length, mass, time, and then you have temperature. Temperature is a measure of speed of molecules. So everything is made of molecules, and it's how fast those molecules move that affects temperature. Energy and motion, and again, you might have covered this in middle school, I'm going to assume, is called kinetic energy. There's kinetic, and then there's potential. Potential is stored up. So when you're asleep at night, and that's why it's important to get a good night's rest, because you're trying to store all that potential energy for the next day. So getting a good night's rest gives you all that energy to be able to get through the day and do all the things you need to do. Right? If you only get 2 hours or 3 hours of sleep, you haven't built up enough potential energy, and after a couple hours on the next day, you're dead tired and you want to go to sleep or take a nap. So kinetic is the opposite of potential. It's moving. And so when we measure, let's say, how hot it is outside, let's say I go outside with a thermometer and I hold it up in the air and it tells me it's 90 degrees Fahrenheit, let's say I'm using the Fahrenheit scale, that means the molecules outside are moving very fast. So temperature is a measure of how fast molecules are moving, what they call kinetic energy. We use Fahrenheit in the United States, right? And if you said 90, you know that's a hot day. If you said 30, you know it's a cold day. But again, in most of the world, they use Celsius. So again, Canada, if they want to say it's a hot day, they might say it's 30. And you say, what, 30 degrees? It's going to snow. No, 30 degrees would be a warm day in Canada. Or if they say it's a cold day and it's going to snow, it might be 0, right? Or even negative 10. So they're going to use a different scale. The one that's not used when you talk especially weather is called Kelvin, Kelvin. Kelvin is really used in science labs. It's used for the sun or stars. There's a chart in your Earth Science reference table. If you go to page, off the top of my head, I don't have it in front of me. It's going to be page 15. So you go to the top of page 15, there's a chart that lists stars, and on the x-axis along the horizontal, it gives you the surface temperature of stars in Kelvin, at their surface. Like our sun has a surface temperature of about almost 6,000. It's like 5,800 degrees Kelvin. So they'll use that to measure the temperature of a star. There is a special number in Kelvin, and it's called absolute zero. And it's 0 degrees Kelvin. And 0 degrees Kelvin is about roughly negative 400, and I want to say it's roughly negative 470 degrees below 0 Fahrenheit. So 470 degrees below 0 Fahrenheit is equivalent to 0 Kelvin. And when things reach 0 Kelvin, what happens is up here, right, we talked about temperature being motion. Motion would stop. All molecules would freeze. They wouldn't be able to move. So the air would freeze. There'd be no molecular motion whatsoever. And scientists have, I don't know if they've reached absolute zero, but they have tried in a laboratory. I know they've done these experiments where they've taken like a clear box and they'll shoot a laser beam through the box, okay, from one side to the other. Now, a clear box, right, the laser is going to go straight through. And what they've done in the box is try to get as cold as they can and lower the temperature in that box, where they've actually been able to successfully stop the laser beam. So the laser will go into the box and then not come out the other side. So they've reached, I want to, again, off the top of my head, I want to say they've gotten down there in the 300 below zero range, 3 something. So they're getting closer and closer to absolute zero in simulating it in a laboratory. But that's, you're talking extremely cold temperatures. So that's where Kelvin's used, stars and things like that. This is in your reference table. This is on page 13, where a lot of the weather charts are. They give you a temperature scale. And they give you all 3 charts. They give you a Fahrenheit scale on the left, Celsius in the middle, Kelvin on the right. Just be very careful when you, like a question they'll throw on a Regents exam would be a conversion. They might say, what is 60 degrees Celsius in Fahrenheit? So you'd find 60 and then follow that line across, and you can see it's a 60 Celsius is equal to 140 degrees Fahrenheit. It's when you get in between the big lines, or they're not matched up exactly, when you got to be careful. This, for example, this Celsius scale, they count by ones. So if this is 60, these little marks here would go 61, 62, 63, 64, etc. till you hit 70. So each little mark increment on here is 1 degree. Same thing with the Kelvin scale. This is 330, and this might be 340, 350, 360, 370, or sorry, let me take that back. 330, 331, 332, 333, 334, 335, etc. So these are also counting by ones. The one that's a little tricky is the Fahrenheit. Because if you look here, right, this is 60, this is 70. But over here, you've got 140, and then it's not 150, it's 160. So you're doubling the scale, right? If this is 10 degrees between, this is 20 degrees. That means these don't count by ones, these count by twos. And that's the one that students will sometimes make a careless mistake on a Regents. So if they said to you, what is 65 degrees Celsius in Fahrenheit? Let me clear this. There's a way to clear it. Yep. All right, so here's 65 Celsius. What is it in Fahrenheit? Well, you come across, all right, and student will say, oh, that's 145, right? They count 141, 2, 3, 4, 5, but it's not. These count by twos, so it's 142, 44, 46, 48. This is 150, right? Makes sense because that's 140, and that's 160, and halfway would be 150. So just be careful when you're counting and converting from one scale to the other. The Fahrenheit is the one that always tends to have a little trouble there with students. These count by twos, right? Each little mark, each little increment. These are ones, these are ones. So it's 2, 1, 1 when you do conversion. So if you look down here at the bottom, you can see toward here, room temperature. So room temp is 20, but that's in Celsius, which is 4 lines above 60. And again, that's not 64, that's 2, 4, 6, 8. So right here is 68 degrees, which is what normally people keep their house at. Some a little lower, some a little higher, but that's equivalent to 20. Same thing with water, right? Water boils at 100 degrees Celsius, but now you're talking, this is 210, and then one line above would be 212, right? So water boils at 212 degrees Fahrenheit. You are 6 lines above 200, but again, you're counting by twos, 2, 4, 6, 8, 12, and that's 100 Celsius. So basic units, no math or no, I guess, algebra, something like that. Whereas derived unit, the word derive means to come up with a solution, right? Derive or come up with the where that word derived from. If you have a word and you want to look at the history of the word and where that word came from. So a derived unit is one where you actually have to do some kind of math. You have to do some kind of algebra, whether it's add, subtract, multiply, divide. So for example, I gave 3 over here. Perimeter, right? Let's say you want to put up some new fence, a new fence around your whole backyard. So you'd have to go out, right, with a tape measure or some kind of measuring device and measure all the sides of your backyard. One side of your neighbor, the other side of your other neighbor in the backyard, across, and then buy enough fencing to cover the perimeter, all the sides, add them up. Or let's say you're going to put down some new floor tile in a bathroom. So you're going to go in that bathroom, you're going to measure the length of the bathroom, you're going to measure the width of that bathroom floor, and then you're going to multiply length times width. That's, let's say you're doing it in, well, we'll stick with the English system we're used to, feet. So that means I'm going to take, maybe the room is 6 feet by 10 feet long, right? My bathroom, that's 60, 6 times 10, right? 60 square feet. So then I'm going to go to Williams Lumber, or I'm going to go to Home Depot or Lowe's or some home improvement place. And when you buy tile, let's say, they're going to sell it by the square foot. So the person might ask you, how many square feet do you have in the bathroom floor? And you say, well, I have 60. And let's say it costs, $2 a square foot. So then you'd say, all right, 60 times 2, right, which is 120. You're trying to figure out how much it's going to cost you to do a project, like put down flooring in your bathroom. So that's an area where you might use area, length, width, or volume. Let's say you're going to go buy a new minivan. You're going to buy a minivan and you want the one that has the most cubic feet. So you're looking at the minivan, you want to look at not only the length of the minivan and the width, but you want to look at the height. And then you take those 3 measurements, multiply it together. Length times width times height. That's going to give you how many cubic feet you have in that minivan. And you can go online even without having to go to the dealership and look up which minivan has the biggest amount of cubic feet. Because you have stuff that you have to keep, bringing back and forth to work or something. And you need a lot of space in the minivan, let's say. Or a truck. Let's say you're going to buy a pickup truck and you want the one that has the most cubic feet in the bed of the truck. Because you're a contractor and you need enough room for all your materials and tools and things. So these are derived units. Anything that you have to add, subtract, multiply, that's where you start getting into a different type of unit where you have to do a little bit of math. So volume is a derived unit, area, perimeter. Those are 3 examples. And this just talks about volume. So the definition of volume is the amount of space something takes up. Like I talked about the minivan. How much space is inside this minivan? So I know how much room I have. Or how much space is in the back of this pickup truck. So if I'm doing the metric system now, instead of cubic feet, same thing. I'm going to measure the length of the bed of the truck in meters, the width in meters, and the height of the bed in meters. And I get cubic. Anything to the 3rd power means I cubed it. So when you see a cube, cubic feet, cubic meters, that's when I'm talking about volume. Volume is always cubed. Area is always squared. So if you see so how many square meters or how many square feet, like we talked about tiling the bathroom, those are examples of area. That little 3 up there, they call that an exponent, right? That's something, again, you probably covered in a math class in middle school, I'm sure. So they call those exponents, so M3 or M cubed. Now, sometimes you need to put a prefix. A pre means before, right? Like a prequel. So you're going to put a word in front of the basic unit and create a totally different unit. So if you take, for example, measurement of distance in the basic unit. So the basic unit in the metric system is the meter, which is an M. Then I can add something in front of that M, any one of these over here, to create another unit. The first one's probably not used that much. Excuse me, it's a decimeter. So if you put a D in front of this M, DM, you're talking about decimeter. Deci means 1/10. Now be careful with deci, D-E-C-I, and deca, D-E-C-A, right? Deca means 10, so you're multiplying the factor of 10. Deci means 1/10, 0.1. So big difference. So if it's DM, it's a decimeter, 1/10 of a meter. If it's DAM, which spells damn, that's 10 meters. Then you have, and that one's not used much, deci or deca is probably not used that much in terms of measurement. Centi is a little c. Centi means 1/100th. So if I had, let me clear this for a sec. Okay, if I put a C here, right, cm, centimeter, most of you know that. So centi means 1/100th. So a centimeter is 1/100th, a small fraction of a meter stick. So you have a big wooden meter stick, and every little part of it is a centimeter. And then you have little lines in between the centimeters. There's going to be 10 of those. They're called millimeters, right? mm. So if I get rid of that C and I put m, now I'm talking about millimeters, right? Very small units, millimeter. So deci, centi, milli are very, very tiny. And then the big ones, like we talked about a minute ago, deca means 10, hecto means 100, and kilo means 1,000, right? So you're driving, again, you're in the United States, you might measure your distance in miles, but in Canada, you're going to measure your distance in kilometers or kilometers, thousands of meters. The other thing is I tell students, if you get confused with these kind of prefixes, think of units of time, right? I think most people know. If I said, hey, what is 100 years called? 100 years is a century, right? Centi. There's the word cent, the prefix centi, which means 100th. So century. Or what's 1,000 years called? Oh, a millennium. When we switched from the 1900s to the 2000s, we changed millennium. Or, hey, what is every 10 years called? The 80s, the 90s, the 2000s. They're called decades, right? There's the deca. Every 10 years. So if you remember those three especially, right? Century, millennium means 1,000, decade. Think of how many years each of those represent. That will help you when you're looking at this part, right? A century has to do with 100th, a milli has to do with 1,000, and a decade has to do with 10. Now, to do some conversions, this is just a basic chart. It says to convert from a larger number to a smaller number, you multiply. To convert from a small number to a big number, you divide, right? If you want to make something a bigger unit. And so these are, again, the basic units in the metric system. Length is the meter. Mass is, the gram. Volume is the liter. And temperature is Kelvin. And these are some other prefixes. And I already gave you kilo and hecto and deca and deci, these guys. There's other ones past that. And if you know anything about computers, right? Back when computers were first getting going, way back when, they measured storage in what were called bytes, which they still do. A byte is so much room for storage. Then they came out with kilobytes, right? A little bit bigger. Then they came out with megabytes, right? MBs. Then you had gigabytes. And now you even have terabytes. So the bigger prefix, the more storage, right? So computers, I remember one of my first computers I had, the Commodore 64 in the mid-1980s, that could only hold 1,000 kilobytes of storage, right? Then you had computers that would hold megabytes, and it was like, whoa, I can put all these pictures on there. Then it went to gigabytes, right? Now you have flash drives that hold, have 100 gigabytes, 128 gigabytes. You can store so much information, even on a little tiny flash drive. So computers have come a long, 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 long way. This is going to hopefully help you when it comes to conversion. You've probably seen this in other classes, but I'll just go through it if you haven't. I call it the stair step method, or the stair chart. So the basic unit is right here. Goes right in the middle of the stairs. Let's say you have 5 meters. I'll give an example here. 5, and I'll put m for meter. And you want to convert that. It's very easy. When you go up the stairs this way, you are going to a bigger unit. You are dividing your number by 10, basically, each step, or moving the decimal. Every time you go up a step, move the decimal one place to the left for each step. If you go down the stairs, you're going to smaller units, right? Taking that 5 meters and turning it into, let's say, 5 millimeters. You're multiplying each step by 10, or basically moving the decimal one place to the right. So if you're going to convert from the basic unit and go up from, let's say, meter to gigameter, you're going to move the decimal one place to the left each step. If you go down the stairs, you move the decimal one place to the right, which makes sense because if you look, you're heading toward the right when you go this way, and you're going toward the upper left when you go that way. And it's just a matter of moving the decimal. So let me clear that. Let me put 5 back in here. So let's say you have 5 meters. When you have the number 5, right, a whole number, you assume the decimal is where? Right after the 5. So the decimal would be right here. So I always tell students, add a decimal after the whole number, right there where the 5 is. So at least you have a decimal to start with. And then I'm going to put it up here so you can see it. Okay. So that's what I'm starting with. Let's say I want to convert 5 meters to millimeters. I'm going to circle millimeters right here. So I count the steps I need to take to get from this basic unit right here to the millimeter. I'm going from 5 meters, converting it to millimeters. I don't count this step that I'm on. I count how many steps to get there. So what I do, I make a little like loop. So I say, all right, I go from here. That's 1, 2, 3. I took 3 steps down, which means 3 steps to the right. So I take that 5 now, I got to go 3 steps right. I move the decimal 3 to the right, and I make little loops going down. So I go 1, 2, 3. I'm going to stick a new decimal here. I'll make it a big fat decimal so you know that's my new decimal. I've got these holes. I fill them in with zeros. 1, 2, 3. And I've got 5, this would be a comma, 5,000. And that would be millimeters, MMs. So if I want to convert 5 meters to 5 millimeters, I went 1, 2, 3 steps down. I move the decimal 1, 2, 3 steps to the right. So 5 meters is equivalent to 5,000 millimeters. Let me do another one with you. Let's say I start here with centimeter. Let's say I have 72 centimeters. And I want to convert, I'm going to circle centimeter. I want to convert that centimeter to kilometers, way up here. So again, I look at the whole number 72. I say, all right, there's a decimal after the 2, 72. I'll put that up here now so you can see it. I want to go to kilometer. How many centimeters is 72 centimeters in kilometers? I count my steps. Don't count the first one. 1, 2, 3, 4, 5. I took 5 steps up. That means 5 steps to the left. I move my decimal now. 1, 2, 3, 4, 5. I put a little big fat decimal so I know that's where I am. I add my 3 zeros. 1, 2, 3. Anytime you have a little hole, fill it in with a 0. That means I have 0.00072 kilometers is equivalent to 72 centimeters. And that's basically how I do it. I don't count the first step. I just count how many steps to get to the place I want to go. And if I'm going up the stairs, I move the decimal left like I just did in this example. Or in that first example, I move the decimal down from when I went from the basic to centimeter to the right. So many steps. Let me do one more just for the heck of it. So let's say, I don't know, let's say we have kilometers. Let's say we have 375 kilometers. And I want to convert that to the basic unit. I want to go to meter. Again, the basic unit is the meter. So I'm starting with kilometer. I'm going to meter. So I count my steps. Well, no, first I put my decimal. Sorry. So let's stick a decimal after the 5. So I have 3, 7, 5. And I put a decimal there. Now I take my steps. So kilometer, I go 1, 2, 3. I took 3 steps down. And when you go down, you go to the right. So 1, 2, 3. I put a big fat decimal. I put 0, 0, 0. That gives me a comma there. And now I'm in meters. So that means 375 kilometers or kilometers is equal to 375,000 meters. And that's it. So that's it for converting. There'll be an assignment that goes with this. Probably I have one where you have to do some conversions. So I will post that also on Canvas. So again, the beauty of these videos, you can go back and watch and rewind if something doesn't make sense, or watch it again quick just to see what I did. And that's it for this video. So thanks a lot, and I will talk to you soon. Bye.